here we are. This is Mike and I. This is our standard slide. Mike with Red Hat and me wearing my Stone Door Group hat today. Stone Door Group does a lot of staff augmentation, and so I've worked with a lot of Red Hat clients, and they know me as a Red Hat consultant. So, but today again, it's the Stone Door cap that I'm wearing. We do have a raffle, so you can stick around to the end. We'll give you a link so you can register for the raffle and earn some swag. All right, so today's Red Hat Open demo is get service mesh and application observability running excuse me, in 1 hour on Openshift. So basically the goal of this demo is to spin up Openshift, show you how to do it. I'm sorry, spin up service mesh, show you how to do it. Demo assumptions. Okay, so this is sort of like where we are trying to define the demo within the context of our expected audience. So there may be some of you that are already working with Openshift and you are curious about service mesh and how to get it up and running. And there may be others who are new to Openshift in that you have perhaps some legacy deployments, and although maybe Openshift was not enough reason on its own to go into containerization or anything like that, the addition of service mesh makes it a little bit more attractive. So let's talk about Openshift just for a few minutes. Openshift is a solution that, and we're talking like high level, broad outline here, is a solution that helps mitigate some of the concerns that you have with your legacy deployments. So some of the challenges we have listed on the slide here would be like multiple deployment environments. You know, if you have a Java application, that Java application may be deployed, you know, into Red Hat's JBoss already, but it may also be deployed into an IBM WebSphere stack. You may have that WebSphere deployed on Red Hat Linux, or that WebSphere may be deployed on Windows, and you may have all of those combinations in your environment. So that can be a challenge. And when you have these disparate environments, it's really difficult to scale. One of the things you need to do, and it's reminded that third bullet there on slow to update new features, is that considering all these variables in your deployments or your customers' deployments, if you're an upstream vendor of the software, the differences in these environments mean that you have to dot your I's, cross your T's, and really be sure of any sort of updates that you want to apply to your environment. Those updates could be the new features or scaling out. You want to add some new nodes to your environment. And then although you have the application clustering, if you're trying to cluster with a new system comes online, you might have a slightly different version of Windows or a slightly different version of RHEL, and those are potential areas of, you know, finding a little bit of mismatch, config drift, and you run into problems. So Openshift, where does that come into play? One of the finest aspects of Openshift is the containerization. Now that's not specific to Openshift. There are a lot of containerization solutions out there, but moving your legacy application from a full operating system stack into a Linux container gives you a lot of portability, a lot of portability, and you know, it gives you an opportunity to deploy into very different environments, regardless of the underlying operating system levels. It's a clustered platform, so a lot of the clustering of applications, that work is done for you. Now, there are some applications that still need extra layers. If you want to take advantage of application level clustering, but with the clustered Openshift platform, you get a lot of the basic stuff, high availability for one, and self-healing is another. So as containers die and you know, stop functioning, what you have is the orchestration piece of Openshift goes in and sees that and takes care of spinning up a new one. And if you've got 3 or 4 of these containers running, and we call them pods in Openshift, Openshift's based on Kubernetes, the orchestrator will then spin up the right number of pods so that you have the entire application running at the level you want it to be running. Those are some of the benefits of deploying into a clustered solution for containerization as opposed to a single, Docker node. In addition to those two things, CI/CD is very popular, so continuous integration, continuous delivery or deployment, depending on your environment. And although, again, that's not anything that's unique to Openshift, Openshift does come with a lot of built-in tooling to make that super, super easy. And it's kind of outside the scope of this particular demo, but if there's time at the end, you have some questions, we can address some of those. At least give you some pointers on where to go for documentation and learn more. And the most recent addition is the service mesh itself. So what is the service mesh? So the service mesh is a framework that allows you to get increased observability and management in your deployed application. What's really cool about service mesh, from my point of view, and historically my background is more platform than application development. So I tend to deal with applications that might be written in, many different languages, and I really can't claim to be an expert in any one of them. And so when the challenge comes to get some sort of application clustering set up with that, it's a lot easier for me to use the advantage of what we call a sidecar container. So again, I mentioned containerization as a general term, something that a lot of folks are interested in. In the Kubernetes world, in Openshift, we call those pods, and that's because you don't have to necessarily have a one-to-one relationship between the container and the pod. The pod can contain multiple containers. And in this diagram here, we illustrate that. So you've got a service that you've deployed, and you've got multiple pods, right? So you got some high availability going there. And then you want to implement service mesh so you can, trace some of the traffic and, do some advanced routing. Say you've got different versions of an application. In order to make that happen, you don't have to rewrite your application. You don't have to go find the right libraries to integrate with Jaeger or any of the tracing tools. All you'd have to do is deploy this Envoy sidecar, which intercepts all the traffic to your application. So again, no change to your application, and you can implement service mesh. And again, from my point of view, I don't have to, jump through a bunch of hoops working with development teams to try to figure out how it works. It works with any application that has already been containerized and made OpenShift ready. All right, so demo goals. We're going to go through a few things here. We're going to containerize a Java application, and we're going to deploy that Java application into OpenShift. And although those are two separate things, that's how one might think of it if you're new to OpenShift or new to the containerization world. The reality is, again, we've got a lot of tooling in there, and using the source-to-image S2I system, we will be containerizing and deploying in one fell swoop. Now, you'll see different pods spun up for each of these stages. So they are distinct stages, but we can do it with a simple command. So again, it'll look like we're doing both at the same time. We are going to leverage OpenShift services in application management. So we'll take a look at how OpenShift sees traffic and how we can spin up additional pods, scale up our application. It's pretty straightforward, again, because we have this clustered framework that we are leveraging. We don't have to build that into our application. And then lastly, we're going to integrate the application with Red Hat Service Mesh. Got some references here. So with regard to OpenShift as just the platform, the first link there is for Stone Door Group's accelerator, the OpenShift Container Platform. And on there, you'll find a white paper and a link to where you can request an OpenShift trial, and we can set that up. And we also have a link on there, I believe it's on that same page, where you can talk to an expert. So you can schedule some time with one of the consultants and talk over, whatever OpenShift needs you have. The second link is a link to the container catalog for Red Hat. And this is a huge, huge advantage to going with OpenShift because Red Hat has its own curated catalog. Some of them are developed within Red Hat. Some of them have upstream, community sort of counterparts. But then, a particular version of that is captured and thoroughly tested with Red Hat products, and then Red Hat maintains that for you. And so when you look at an application, there's nothing stopping you from grabbing a build container or a runtime container off of, key.io or docker.io or, just some random place. But if you pull it from the Red Hat catalog, you gain a little extra layer of support, and it's just really handy. So we've got all the S2I tools and stuff built into them and so on. The third link there is docs at openshift.com, a very, very valuable resource for anybody that works with OpenShift. Lots of YAML code examples. And a specific subsection of that that's germane to today's demo is the OpenShift service mesh. So that deep link there, version 4.5. I think my cluster that we're using for the demo today is actually still 4.4, but the docs are updated to 4.5. And under service mesh section, you can see there's this understanding OSSM, OpenShift service mesh, and you get started there. And we may look at that as we progress throughout the demo. Okay, so I just stole my own thunder. This is the closing slide, so I should have just jumped into the demo. Let's go ahead and do that. All right, so here we have a cluster. And what I'm going to do today is start with the demonstration of some of the interfaces so you can see what we're shooting for. So we've got service mesh. If you've never heard of it or never worked with it before, you may be asking yourself, well, what's it look like? Let's start with that. And then after we go through some of the interfaces, we can go through the process of spinning it up for your project. So here we have some ready-made projects. This one is my application, the employees application. In the workloads here, we can see the pods that are listed. So we've got a bunch of pods running. And again, these pods are, not the equivalent of a container, but a grouping of containers. You can see this ready column will tell you how many containers are in the pod. So this MySQL, he has no sidecar container. That pod has one container. These others that have the OpenShift Service Mesh integration have 2 containers each. So that's what we're seeing there in that column. Deployments. So we've got a couple deployments there. We also have deployment config. Roughly the same thing for the purposes of this demo. We're just going to treat them as equal, and that tells OpenShift how to manage the stuff that's out there. So when we go to scale these things, we want to spin up and turn a 1-pod application into a 5-pod application. We'll do it against the deployment config. This is like our desired state, if you will. In fact, here's a way we can spin that up there. May as well look at some. Here's some stuff here. So on an image change, we can trigger, an update on this deployment config. Then there's a bunch of stuff down here, listening ports. Here's the image that we're running. It's called Spring Boot Demo, but it's pointing to this internal image registry. So this image registry OpenShift-image registry.svc, that's an internal address pointing to the image registry that is built into OpenShift. Let's go back to the pods. Don't have, please, the demo. Oh, these are the running pods. Let's see, the completed pods. There we go. And if we turn off the running ones. So this is a way of looking at the the pods that were used to build and deploy. And if I look at this build pod here, check the logs. They're handy in case your build fails. And you see it's downloading a bunch of stuff, and then it builds the runtime image. So that's if you're familiar with Docker Podman builds, this is the sort of output you see, and then it pushes it up to the registry. So this is the build pod. And the deploy pod, which is also completed, is we've got two of them here. So the first one is the initial deployment. And then when I updated the deployment to include the Istio sidecar or the Envoy sidecar, then the deployment was automatically updated and it spun up a new pod. So again, the application was only built once. That's because we didn't change anything with the application container. We're only updating the pod by injecting the sidecar. And so we got a second deployment here. And if we wanted to, we can see the logs on that one. And it's pretty straightforward. It just went from demo 2 went up to 1. And demo 1, again, these are the version numbers of the deployments, go down to 0. All right, so we got an application running. Let's see what it looks like. So if we go down to routes, here's our demo. And the route is application is not available. No, that's live demos for you. We'll see what when we get around to. Oh, I know what's wrong with this. We'll not get into this. When we walk through the steps of spinning this up, it'll be working, and we can talk about why this is not working at that point. But at any rate, so we've got this demo application running, and what we can do is run some traffic against it and see what it looks like in the various service mesh interfaces. Let's go ahead and start that. And there's a traffic test script here. So now I'm running a bunch of traffic against this application. And we'll come back to, so this project here, CJM employees, is the project for my application. It contains the sidecar, the Envoy sidecar, but the service mesh itself, the thing that collects information and provides the interfaces, all that stuff is in a separate project or namespace. And that same service mesh control plane can be the service mesh for multiple different projects. And so that's why it's often its own little space. So if we look at CJM service mesh, we can see there's a ton of stuff there. When we deploy it, we look at pods we've got a ton of pods. And so it's Istio pilot, Istio policy, and so on. Jaeger, Galley, Prometheus, bunch of stuff. To access those interfaces, we're going to look at the routes. And we'll start with Grafana. Grafana is the tool for visualizing metrics. So as we come in here, so we've got some of these Istio dashboards that are shipped with the product. There are more in here. If you go this, oops. We can grab another one of these. Let's see, performance dashboard. And you can see there's some activity on here. So bytes transferred. It was dead there. I was not running my traffic generator, but now that I am, you can see there's stuff coming in. So if you want to do this in real time, you can do that. If we again, there's other dashboards showing other things. Here's some CPU activity, some disk activity, and so on. And there's a ton of these dashboards. We're just highlighting that they exist for this particular demo. Okay, the next interface that we're going to look at is Jaeger. The Jaeger is the interface that we use for tracing the applications. So if I want to find a particular service, and let's look at candidate CGM employees. We can go ahead and find some traces for that. And here they are, a bunch of different traces with different activities going on here. This one took really long. It's 80 milliseconds. And these down here are more on the order of 20 milliseconds. So you get a bird's eye view of what's going on. And you can kind of come up here and just click on one and see what the trace looks like. So what's happening here is we've got an ingress gateway. So this is where the traffic is hitting. And the various traces here, or spans, they give you an indication of how much time is spent in each of the stages of communication. So when it hits the ingress gateway, the traffic is then forwarded to candidate.cgm employees. And then candidate CGM employees goes to titles.cgm employees. You can see on the fine print. And then titles just keeps it, right? So titles is where the real work is being done. So that's why this particular span is shorter than the rest. So it starts here, it takes X, if I can eyeball that, 4 milliseconds maybe, that is processing it before the candidate CGM employee service takes over. And then it passes it along. And then this little handoff here between these two is very efficient, meaning the handoff, it takes very little time for the next step in the process to start executing. And also the return is very quick as well. All right, so that's what the tracing looks like. And then we're going to look at Kiali. So if we look, and again, we're just going to scratch the surface of some of these things here. So we're going to select the namespace. So if we look at CGM employees, you can see what the graphical representation of the traffic looks like. So we've got this candidate service coming in. It's hitting version 1 of the pod. So the service can, we're not going to get into today's demo, but what you can do is spin up multiple versions and do some custom routing. So a candidate can send like 10% of the traffic to version 2, 90% to version 1 if you want to do some sort of canary testing or whatever before you roll up to version 2. And that's passing it along to this titles service, which again also has the same capability. And then it's hitting this MySQL database that we have set up. Now the traffic does come in to that Istio ingress gateway, but that's in the other project. So when we show that, we'll click here and add that into our things, you'll see that it looks something like this. And so it's a little bit more elaborate, but you can see where the traffic's going. You get some information about it if you like. All right, so that's the Kiali interface. Prometheus is pretty standard. If we click on that route, you see what Prometheus looks like. So on our service discovery, got a ton of these things here, and I've done a fair amount of work with Prometheus, but I haven't really looked at the integration with service mesh in detail. So I'd like to click around, but there's not a lot to show you here. But if you look at, let's see, we've got one here, Kubernetes pods. Yeah, so Jaeger's, so it's the Jaeger pod, I guess. You can also see the status of the targets here. So it's hitting this pod, that pod, and so on with these particular paths. So here it's gathering some stats for Prometheus. And so yeah, and Envoy. So here's where Envoy is the target of the Prometheus scraping, right? So you've got 7 of these guys going, and it's grabbing all the information. You can see the last scrape was 4.9 seconds ago. Scrape duration is 3 milliseconds. So that's pretty cool. you have to be judicious with your scraping. I've got a project now where we're starting off and it's a 30-second scrape, and that's not because of underpowered hardware. It's because our config is just too wide open. So we're actually working on that to tighten it up a little bit. And then if you want to see some of the information, you can come over to this graph section here and grab something here, STO. And like I said before, I'm not really familiar with all these. So quest bytes, count, execute. Here's some stuff. If we look at the graph page, there we go. It's all pretty level, because I think because of the nature of the traffic generator. Probably add different sleeps in there so we get a little bit more jagged line. Assuming I've got the right parameter here for looking at this. So anyway, those are our basic service mesh interfaces. So let's come back around now and show you how to get it all set up. Okay. And the first thing we're going to do, and I've got, we did a virtual workshop a little while ago where we had a student set up service mesh. So I'll just be clicking through that to show what we should be doing. The first things first is you would create your project and deploy operators and so on. So I come over here. I'm going to create a new project. So see projects. And I'm just going to kind of mirror what's already set up there. So let's see, new project, PJM demo, service mesh. And we'll go ahead and deploy service mesh. Actually, I think these instructions have the application first. So let's do that one. Employees. Okay, so we've got our two projects that we're going to be using. Let's come over here. And so I did an OC new project. First thing we're going to do is set up MySQL, and we're going to run this command here, which for those of you not familiar with Openshift, it goes into our template library that comes with Openshift and grabs a template. We can provide some parameters, those username, password, and so on. And the employee is the name of the database, and then we can create it. So this process thing takes the template and substitutes the parameters into a YAML file, basically. And this OC create -f minus means it's pulling it in from standard inputs, so kind of standard Unix functionality there. Go ahead and do that. Take a little detour here, show you what that may look like, what we're actually doing. And we'll do it two different ways. We're going to get templates in the OpenShift namespace. So you can see there's a ton of them in there. If we look for just SQL, we got a bunch of them here. All right, so MySQL, Postgres, some other ones that have more integrations like SSO and so on. So those are all in our template library. You don't have to know about this. All these commands you can. I'm jumping around here a little bit. Here we are. You can just when you go to your catalog, you can see it there. So like a developer and add. So here we can add application from Git, container image from catalog. So if I click on that, you'll see that there's a ton of stuff. So operator backed, you uncheck that, you got them all. So here's .NET Core, Postgres. So these are all the same sort of templates that are in that templates file. In addition, from this developer catalog, you can grab things that are operator based. Okay, so where did we leave off here? So, okay, so we got our projects. We have deployed, not what I want. We have deployed the MySQL database. What's next here? Oh yeah, so now we're going to RSH into the pod and create a couple tables. So the pods, the RSH, get the pod name here. So again, this one has a deploy pod. There's no build because we're not building it. It's a pre-made one that comes from the Red Hat catalog that we were talking about earlier. Switch into there. You get a standard shell. I prefer Bash. And I like a slightly different Bash history editor, command line. And so the next thing we're going to do, once we're RSH'd in, we're going to log into MySQL. And we're in MySQL now. Now we're going to run some commands. And I'm going to do this one at a time, copying and pasting from here. Sometimes I get some control characters that don't behave well. And also I sometimes copy I need. All right, so we're using that database, and I create the table. I think I can do all this. Yeah, so no errors there. So we created a table. We inserted some folks. I get the last one in there with different titles. So we're going to do an employee search later on. So just quit exit. The quit gets us out of the MySQL application. We are still logged into that container. Right, so we're in that container. And if you want to do something, let's see, stat. Yeah, so this again is a runtime container. It's really cut down. You're not going to see these sorts of things. So there are tricks to gathering information from pods if they don't have tools in them. You can download just sort of statically compiled tools into the running container. You can, if you're familiar with the proc file system, you can grab the information you need from there, and that's a common thing we do. So next thing is to deploy the application. So we're going to use the OC new app command, and this is where we can see the S2I process in action. So OC, all of our commands are going to begin with OC. If you're familiar with Kubernetes but not Openshift, it's basically the equivalent of kubectl. OC is a wrapper, so we have a few additional things. At one time, Kubernetes didn't have this new app. I'm not sure if they do or not. I don't really keep up on the latest greatest with the Kubernetes since my day-to-day job is with Red Hat Openshift. So new app allows us to spin up an app in a lot of different forms. We can point new app to a container. We can point it to a template, either a template from the Openshift catalog or a template that we've created, a custom template. In this case here, we are using a very cool feature. It's called S2I. And what we're doing is we are pairing up this image, registry access, redhat.com, is the your registry. Here's your namespace, and here's your container. We don't have a colon latest or a colon version number on here, so it may not be obvious, but that's what that is. That's your container image. You give it a little tilde, and then you can point it to a Git repository. Now, S2I is pretty smart. If you skip the container image, it will look at your Git repository and try to evaluate what kind of image is needed. And that works for a lot of common languages out there. So if you've got, I'm not sure what it looks for in the Java one, but for Node.js, it looks for like the package.json file. And if it sees that, it assumes Node.js and so on. But it's often pretty good to specify a particular version of the container if you've got some sort of version requirements that go into your application. And then there are a ton of options to the new app command. And one of the options we're using right now is just giving it a name. So this name is going to be Spring Boot Demo. It gives us a little control over how it looks. And so when I hit go, see, there we go. I'm still in the MySQL container. I did the quit. I never did the exit. So let's drop back out my command line. And this will not be my history, so I'll have to copy and paste it from here. There we go. So we've got this thing running. See, so OC get pods will get you a bunch of pods. If you add a -W, it'll give you a watch. This is sort of like you could do this. You could do watch OC get pods, and that'll update every couple seconds there. So right now you see it's updating this age column, right? So 26 seconds, 28 seconds, and so on. The difference between that and the -W is that the -W gives you the previous history. So right now, it's just going to append any changes to those things to the bottom of the list. So you can kind of see the names of everything. So as pods come and go, you might want to know what was the previous pod's name, but it got deleted because we just ran an update to our deployment config, and the deployment config or the orchestrator deleted the old pod. But if you're doing a watch like this, you'll see those updates. If we wanted to follow the build there, we could do this. I'm running screen, so I just popped into a different thing there. So let's see the pods. So we can run OC logs -F to watch the build. Now this is the equivalent of what I showed you earlier in the web interface. So all this stuff, there's the pushing and so on. All that is what we've got here. I'm in demo employees, workload pods, completed. Sorry, completed. So here's the build. So that's all this is. What we see here is the equivalent of OC logs. All right, so application is being deployed. Find out where we are with our OC get pods -W. And it's running. So while that's going, we are looking at the time. We'll get to the deploying the operators. So in this configuration, it makes the most sense to kind of deploy these to all the namespaces. I'm not going to be able to deploy all the operators, but I can show you what they look like. So in OC demo employees, you can go to this operators section here, and look at the installed operators. So I've already deployed these to all namespaces. When I created this project, the operators are automatically associated with it. And so they are available to spin up the various custom resources that these operators provide. To give you an idea of what the operator deployment looks like, let's not do it in this. Let's do app demo. I don't think I did anything with that one there. The app demo also has that. So we'll deploy an operator so you can see what the process looks like. So we've got Kafka here. So let's take a look at this one. Red Hat integration AMQ streams, which provides Kafka. When you deploy an operator, it looks something like this. You'll get some information. You can read up on exactly what the operator provides. And then you can click install. And then you get some installation options. So you can deploy to all namespaces or into a specific one namespace. So in this case here, I'm going to do one. Now, some don't give you the option. Some of them are designed to be throughout the entire cluster. The Service Mesh one, at least in this version of Openshift, required that operator to be deployed on the entire cluster, all namespaces. That, and I think Jaeger also had that. So again, it made sense just to deploy them all the same way for the purposes of the demo. You can go ahead and pick up different version numbers here, approval strategy, and so on, and hit subscribe. And what it does is when I click subscribe, it'll deploy the operator in there. And in these provided APIs, these are new resources. So we're looking at pods and services and routes. When we deploy this operator, we'll get these new resources. There'll be a resource called Kafka. So you can create a Kafka, and that Kafka will have various components to it. You can create a Kafka Connect, Kafka Topic, Bridge, and so on. I'll go ahead and hit subscribe, and deploying. Anyway, that's what you get. So then once you have your operators deployed, you can take advantage of them. So come back over to demo service mesh, and I'll click on Red Hat Service Mesh. And so here are the various things you can create: a control plane, a mesh member, and a mesh member role. We're going to create a couple of these things. First thing we're going to do is create a control plane. And you get this YAML, and you think, oh, great. How do I configure this? Well, that's why one of the links is the Openshift Docs. So if you come over here, understanding Red Hat OpenShift, you can see in the nav column here that we're just here at this level. If you look at Service Mesh installation and click on installing, here's where you can get some more information. So we've got the basic installs. And, oh, that's true past it. Jaeger installing. It's in here somewhere. Creating member role. Customizing. Yeah, that's it. There you go. So the basic install, you can see it's similar to the one we just fired up, but we can specify all these things, and then all the parameters are further down here. So each thing is described further. There's also a thing called a custom resource definition, where you can see what's going on there. So, let's go ahead and create this. And if we look at pods in this one here, you'll see that it's going to start spinning up pods for our demo service mesh. There's Prometheus. Okay, so while that's running, let's continue on with these things here. So Spring Boot demo, we're going to, oh, that's why the, wait. Okay. There's the Spring Boot demo. We're going to write project here. Employees. So right now, to show you what's going on, I see get services. We've got a couple services, one for the SQL database we set up and one for our app. The route is how we reach that application. We don't have one, but if we expose the service, it creates the route. So now as you get route, you can see there's a route there. If I connect to that route, then we will be able to see the application actually running. So going back to demo employees, all right, this is where my app's running. We're going to go down to the networking section, look at routes. Greetings from Spring Boot. So we're actually have to hit, a deeper path. Copy this one here. Try to figure out what title Kenny has. Kenny's a consultant. And Mike is an admin, and so on. So that's how this simple application works. Okay, so service mesh we already did. All operators. This workshop is a little bit different. We're going to get a bunch of pods spun up. I showed you that in the web UI, and probably just continuing along.
Hey, CJ.
Yes.
In the chat, Shashi's asking that it was the service mesh, you'd already deployed it, but they're asking, was Istio deployed again for the project in what you just did? Maybe you could touch on that. Maybe that was the operator and what it deployed.
Yeah, that's a good question. So the operator, so operators are new in version 4, but as you see, we're like on version 4.5 of OpenShift, and so that has been familiar to me for a while, and I sometimes take that for granted. I know there's a lot of clients that we have that are still on version 3 of OpenShift, and operators were introduced then, but they were not as integrated. They were just, they're integrated enough, but it was not like the way that OpenShift 4 is with the way off. So if we go back, what is the operator? Operator is a pod that's running that will help you manage your environment. And so when I created, see here, so we can't really see it too well in the, if I go up here, it's all operators, service mesh, and control plane. So when I created this control plane, it created what's called a custom resource. And this resource is called a service mesh control plane. So like we did with before, demo service mesh. So by supplying this N, I can run commands against that namespace without actually changing my context, which is handy for now because we're going to, even it's left and I don't want to get lost in the map forks. So what was that called? Service mesh control plane service. So I want to get pods, right? Those are the pods that are running. Well, now there's a resource called service mesh control plane. And that's what we created with this create service mesh control plane button, right? So we created this. We're going to create one that's called Istio service mesh member role. There's nothing up my sleeve here. It doesn't exist yet. And if I do, let's see, Istio, what's it called? Service mesh member role. To spell it. Yep. Oh, it's just service mesh member role. That's the name of the resource. Right, so those resources don't exist yet. And that member role is going to tell the service mesh, which projects it is managing. So let's go ahead and add that next. Hopefully that answers the question. All right, so where were we? Pods are up. There's member role. Okay, so we're going to add our, we're going to create this. And so it's a simple one. The namespace that we're creating it in is this one here, but the members will be the namespaces of the project. So we're going to say, let's go ahead and manage CJM demo employees. We're just going to manage that one project for now. So we've created that object, and if I come over to here and I do a listing on that resource type, now we got it, and you can see it's 8 seconds old. So that's the cool thing about these operators, that it'll, like I said, spin up pods. Like we didn't define any of these pods. We just said, here is what we want our Istio to look like, or our Red Hat service, OpenShift service mesh. We want it to look like this. We did that in one single configuration file, which was this one over here. And control plane. Here's our Istio. A lot of stuff, you remember the original YAML is not this elaborate, so a lot of it's kind of just built off of defaults. And you get all this good stuff. And it takes the operator takes this information and then creates all the other things, the other workloads you want to see. So we'll have some deployments. Here's deployments for Grafana, do ingress gateways, do galley, all this other stuff. Pilot, policy. And of course, those will have corresponding pods. They will have corresponding services. And they'll also have this corresponding routes. So instead of me piecemeal trying to deploy all these different deployments, like we did with OC New App, the operator handles that for us. So for these complex solutions, the operators are a way to go. With a simple solution, operators are still pretty cool, but they can sometimes be a handful. Okay, so we've got now our service mesh up and running. If we go ahead and look at that, routes, and let's just do our Jaeger. And log out to OpenShift, EP user. You don't have to do this the first time. Subsequent logins are ready to go. So select a service. No results found. That's because we haven't really added our application to the service mesh that we just spun up. So that's our next step. Okay, identify service mesh URLs. Okay, so here we're going to go back to our application and we're going to add this one line. Sidecar is to inject true. So that's where it's going to take our single container pod and add to it the sidecar. So again, our demo application here has one container. See edit. Was it a deployment config? Yes, it was. And we'll come down to no, it isn't. Okay. Yeah, actually, I had both of them in there. DC Spring Boot demo. You do OC edit DC or deployment config, it'll edit all of them, so you get it all in one big line there. We don't want all of them, we just want this one. Annotation here. And with this simple line, with a bunch of control characters, we'll okay, didn't like that because of stuff. Okay, so let's try that again. Get a cleaner, cut the paste now. That's better. So this is where we get that second deploy that I showed you at the beginning of the demo. And it's going to be spinning up a new version of things. So you zero up 2 containers, creating a container, creating another container, and then you'll have the new app is running with those containers, one of which is the Envoy sidecar. So now, if we come back to our Jaeger interface, reload it, we got Jaeger query, simple service, and bang, you've got Jaeger talking to the sidecar. Now we have to create those services and routes. We have just a few minutes left. Go ahead and get those in here. And that's where these guys are. And you can pull these down and look at them. But here is one of our sources. And all right, so we've got a bunch of stuff in there. We created a service account, deployment, and another service for titles, and so on. the next piece here, the gateway stuff. All right, so we created a virtual service called Book Info and another gateway service there. And the last thing we're going to do is create a rule. Destination rules are then created. I believe traffic. Okay, so we probably want to run our traffic some more. Traffic test. That was in the other environment. So export role plane demo service mesh. Yeah, so we're running some traffic now against the application just deployed, and then we come back with a minute or two to spare and see now that all these services are here. So to integrate it, we had to create those extra services, the RAS, the ingress gateway. Those are all part of the setup here. If we search, see we've got all the stuff with the multiple spans. If we look at Yali, again, this is the demo namespace, the one we just did during this demo period. You'll see that all that good stuff was created too. OpenShift. All right, we'll go back to Graph, namespace, go ahead and grab both of these, and there's our complex app. So the last thing we did these initially, we did the MySQL, we did that manually, we deployed the application with the OC new app, and then just with some offline templates, really love, maybe we could do this sometime, have like a couple hours to get into all the nitty-gritty details. But you can see here that we've got that elaborate thing and just right at the 1 hour mark. So hopefully that's considered a success. Let me come back to the slide deck here. So those links that I was talking about earlier, this is what the container platform accelerator looks like with various things. So you can request talking to an expert there. Your container image site looks like this. With docs we looked at. A couple more things. Again, this is coming from a workshop we did a few weeks ago, and those are like 3 hours where we provide you with hands-on labs, and those are really fun because we do have time to get into nitty-gritty. You get to break things and ask questions, and it's a lot of fun. So if you go to just Google for Red Hat events, you'll get this link, and of course you probably received a link to this site, but if you didn't, if you got a deeper link, directly into the open demo registration form for this open demo. If you want to find more open demos, just go to redhatdemos.com. And sorry, we're going over just a little bit. Let me take it back to the slide deck. Again, just another indication of where you can go for information. There's a Let's Do This at standardgroup.com email address. And then here is the information on the raffle. So there's the link you should look at if you want to try to get some swag. And with that, Mike, I'm going to hand it back to you for close up. And again, apologize for running a couple minutes over.
No problem. Thank you, CJ. That was excellent. Personally, one of my favorite topics. I love service mesh. So what I'm going to, for those of you who want to, maybe see this again, look in the chat. I was answering some questions as CJ was presenting, but one thing I wanted to provide is there's more information and a lot of the links that CJ was just touching on. Here I'm providing a link to our developers.redhat.com site devoted to Service Mesh. All kinds of information, resources, walkthroughs there, videos, etc. This demo session today is being recorded. We will be posting it at the Bright Talk site. You can go there to see previous open demo recordings, various other Red Hat recordings. This one will be available shortly, probably within the week, and you can go to there and then search on, Service Mesh, Openshift, etc., and you'll be able to check it out. Also, I invite you to visit the Stone Door site. They're posting a lot of the recordings they do there as well. And as CJ said, make sure to email Let's Do This at stonedoorgroup.com. I believe that's right. Is that right, CJ?
That is correct.
And if you're wanting to get in on some of these, really deep dive hands-on technical sessions, email and ask for more information so you can take part, have a lot of fun at the same time. So with that, I want to thank you all for attending another Red Hat Open Demo session. Make sure you hit that July Open Demo raffle link to enter a chance to win the Amazon gift card for $50 plus a Red Hat New Era polo. Thank you for your time today. We'll look forward to seeing you at the next session for Red Hat Open Demos. Take care, everyone.